Hello, my name is Jonathan Iliff. I'm going to tell you a little bit about SnakeGrid Local, which is a plugin for the FME system. Starting point for this is an engineering project. Let's say this simple little example here of a railway crossing a road bridge, just like that. It's quite common practice in engineering to devise a local coordinate system, maybe by introducing control points with one of them assigned to the role of a datum and given some rounded set of coordinates, maybe another direction to another point assigned as an orientation. And then you carry out a quick survey, a little survey of those points by traversing and so on to assign control points, the coordinates to those control points. What you've established there is a local engineering system. And that's a great kind of system because it's got a one-to-one relationship between the coordinates and the ground. There's no problem about scale factor or anything like that. There's no question of reductions to sea level, etc., etc. It's a simple one-to-one relationship. It's great for that kind of local work. The trouble with it is that we don't know what its relationship is to the outside world. And so if you want to introduce other data, which is related to something like the ETRS-89 system, for example, geographic coordinates in that, or data related to the national grid or the state plane coordinate system or anything like that, what is unknown is the relationship of that local engineering system to the outside world. So that's the link that we have to establish. Typically, what we will do is to carry out some sort of a GNSS survey on those known control points. And then if we can find the links between the local grid coordinates in that engineering system and the ellipsoidal coordinates established by GNSS, then we can derive a transformation between them. That transformation normally looks something like this. This example is showing on the ETRS-89 datum, which is a standard in Europe, but you'd have equivalents anywhere in the world. And essentially, to find the connection between the geographic coordinates and the engineering datum, we normally do it in two phases. One is that we introduce, first of all, a local transverse Mercator, which is designed, tailored for that particular project. And then, going from that, in another step, we carry out a similarity transformation, rotation, shift, possibly a scale change, to get the connection between the locally projected coordinates and the engineering datum. And those two steps are bundled up together into one transformation between the two. That's done by quite a lot of manufacturers' software. It's a relatively standard kind of procedure to adopt on an engineering site. Sometimes the problem is that the parameters for that can be simply stored in locally to the manufacturer's system, and then they don't become sort of transportable into other systems. So that's what we're doing with SnakeGrid Local. And then the output of that is two types of output. One is that it's simply giving you a report on what those two phases of the transformation were. So if you wanted, you could take that off and you could give it to somebody else to program into any other application you like. You could put it into an Excel spreadsheet or something like that. But the other output is a parameter file in the SnakeGrid system for that one. So this example, the parameter file is in the local system bridge 2943, which was referring to that specific engineering project. The advantage of that is that SnakeGrid parameter file can then be fed into any of the other software that uses the SnakeGrid system. SnakeGrid Projector, SnakeGrid Pointwise, SnakeGrid Transformer, or any of the third-party software that produces that. So you can pass that SnakeGrid parameter file around, and everybody is using a common way of referring to how that engineering project links to the outside world.